In the diagram, we are given that angle at A, angle at B, angle at C and angle at E are 90 degrees and AB is 22, BC is 18 and DE being added with EF, it's equal to 28. The last one they are saying AE's length, it's equals to DC's length. And what do we want to do? We want to find the area of this particular figure. So let's begin with the thought process. If I want to find the area of the figure, then I know that I will take the area of the whole rectangle, which is quite easy for you. You're going to do 22 times by 18 and then you will minus off the unwanted region. What is the unwanted region? Okay, let's connect F to the D and you can see that you are having a 90 degree at the E. So this is a right angle triangle. So I can do area of triangle DEF. So in order to do this, you will do half times by DE times by EF. And we got to minus off the other part, which is here. This is also another right angle triangle. I'm sure you can make sense that this corner, let's label this as M, is going to be 90 degree as well. Now, what is the gist of this question? It is quite simple. At this point, you should know that, let's say I label this as P. So this area, let's label this as P. You should know that the area of the P, it's exactly going to be equal to the area of the Q here. Why are they equal? Now, in a while, I will illustrate by drawing. But let's take this concept and solve first. So I know that I am going to just take the area of triangle DMF, or I can just do times by 2. So 22 times by 18, we are going to get 396 minus by DE times by EF. If you can find what is DE and EF, then we are done with the question. But how are we going to find the DE and EF? What information is given to us? They have said that DE plus by FE is 28. And we know that I can apply Pythagorean theorem. So how do you write the Pythagorean theorem now? We can do DE squared plus by EF squared is equals to DF squared. I know that DF is the longest length in the triangle. And maybe a little judgment will tell you that EF will be definitely lesser than 22. And your DE will be lesser than 18. You can see that from the figure itself, based on the information given. Now, which Pythagorean triplet will help you to do this? Okay, let me write the basic one. Can we take 3, 4 and 5? The longest length here is the 5, right? So this is the hypotenuse part. Your hypotenuse is definitely the DF. So what is 3 plus by 4? Is it equals to 28, like what you want given? Of course not. So we are not taking this. What is the next Pythagorean triplet that you can think of? Can we do 6, 8 and 10? 6 plus by 8, it is just 14. Still not 28. You don't want that. Okay, well, how about the next one? 5, 12, 13. 5 plus by 12, I get 17. Still not helping me. What is the next common one? How about 9, 12 and 15. 9 plus by 12 is 21. So we are not getting it yet. Maybe we can do 12, 16. 12 and 16 is definitely 28, almost there. So you know that 12 squared plus by 16 squared is equal to 20 squared. So this combination works. So once you are done with that, it becomes easy for us. So maybe the DE could be 12 and this one is a 16, and we know that the length of DF is going to be 20 now. So by that, 396 minus 12 times by 16. What is 12 into 16? 192. And the final answer is 204 units square. Now, as I promised earlier, let's do the illustration part. Why is the area of P and the area of Q is going to be the same? So I have gotten a rectangle here, and let's measure. I'm going to take that this part being the x, and here is also going to be the x. So to do that, can you see I'm putting the edge over here, and let me measure a 6. If this one is a 6, the opposite part is a 9, right? So I'm going to do it this side now. So if this is x, this is going to be x. We're going to merge the line. Okay. So let's try to fold it. To let you see more clearly. Can you see that this length, if let's say this is a y, here is also going to be a y. If this is a z, here also going to be a z. We write a z here just now, and this was a y. So I hope you can see this. And we know that this part is a right angle. Of course, this edge is also going to be a right angle. So can you see that the area of the P is exactly area of the Q? So this is the gist of the question. Of course, together with the Pythagorean triplet. In case when you are solving, you don't see this idea of area being the same, how can you solve it? How can you solve it? Let's say if you don't know. What you can do, you can write here as 22 minus x. Let's label this one as our x. We have a 22 here, so this is going to be 22 minus x. So here it will be 18 minus x. And you can apply the Pythagoras theorem because of the 90 over here. And you can do 22 minus x squared plus 18 minus x squared is equal to 20 squared. A quick expansion will be able to give you the appropriate x. So what will I get? 22 squared minus 44x, x squared, 18 squared, 36x, x squared equal to 20 squared. 2x squared minus 80x, and into the calculator, it is giving us 408. Divide everything by 2. And you can quickly factorize. 36 and a 4 will give us 204. 34 and a 6. Can the x be 34? Your length of AB is only 22. So there is no way your x can be 34. So the x is exactly 6. If you know that the x is 6, you know that this is going to be 16 and this one is going to be 12. See, 12 and 16. And that's what we're getting here, 16 and 12. You can also solve it in a longer method.